In calculus 7, we're going to look at the exponential function and the natural logarithm function. Let's take the first one here and do a bit of differentiation. What if y is equal to the natural log of x? We can say that x would have to be equal to e to the power of y. And based on our rules of differentiation, where e to the power of x goes to e to the power of x, dx dy is equal to e to the power of y. So therefore, dy dx, if we invert these fractions, is equal to 1 over e to the power of y, which is equal to 1 over x, as up here x is equal to e to the power of y. So the natural log of x goes to 1 over x. E to the power of x goes to e to the power of x. E to the power of ax goes to a to the power of ax. And a to the power of x goes to a to the power of x by the natural log of a. So let's have a look at some simple enough questions in relation to these. Differentiate the following with respect to x. Same question all the time. E to the power of 3x is equal to e to the power of ax. So it's going to go to 3e to the power of 3x. They don't get massively difficult, these exponential and log functions. We could use the chain rule to do this, but there's absolutely no need to use the chain rule. What about e to the power of minus 7x? That's going to go to minus 7e to the power of minus 7x. So we apply the chain rule to this first one here. We could say y is equal log to the base e of ax. So y is equal to log to the base e of v, where v is equal to ax. So straight away we can get dv dx is equal to a, the coefficient of x, dy dv if y is equal to log to the base e of v. From up above, this is going to go to 1 over x. So dy dv is going to be equal to 1 over v. So dy dv by dv dx, you can see, is dy dx. So dy dx becomes dy dv, which is 1 over v, times a, which is dv dx, and 1 over v is 1 over ax. So we just end up with dy dx becoming 1 over x. So let's have a look up here. Log to the base e of 3x. Second one, you can see, is similar to the first one. So when we get down to, if we use the chain here, we're going to get down to this point here where we have 1 over ax times a. So we're going to get 1 over 3x times 3, which again is going to give 1 over x. So you should see now that if f of x is equal to log to the base e of another function, let's say g of x, where g of x in this question is 3x, f prime x is going to be g prime x over g of x. And you can see in this case that would be 3x differentiated will give 3 over the original 3x, which is going to give me my 1 over x. So let's apply that rule up here. So f prime x for this one is going to be g prime x, which is the bracket differentiated 2x over my original function x squared plus 1. So these become really easy when you apply these set of rules. In this example, we're told y is equal to a to the power of x. Find dy dx. Now we know the answer to this from up above. A to the power of x goes to a to the power of x by the natural log of a. So the answer here is a to the power of x by the natural log of a, which is the same as a to the power of x by the log of a to the base e, these natural logs. So let's look at expanding this. So y is equal to a to the power of x. If we get the log of both sides, or the log to the base e of both sides, log to the base e of y is equal to log to the base e of a to the power of x. So we can now say, based on our rules of logs, I think it's law 3 of logs, where we bring this x in front. So x, the log to the base e of a to the power of x is the same as x by the log to the base e of a. And now we can actually isolate x on its own by dividing across by log of y to the base e. So log of y to the base e is equal to x. And I just put it should be the y on top and the a in the bottom. So I can separate this into two parts. I can say that x is equal to 1 over the log of a to the base e times the log of y to the base e. And if I differentiate this with respect to y, I'm going to get dx dy equal to, it's like 5y. I'm going to have 1 over log to the base a of e times 1 over y, the differentiated part of this. We imagine that as product rule, it would be the first by the second differentiated. First by second differentiated, as we has here, plus second by first differentiated, which would give me a 0, because there's no y in this part. So the product rule is what's being applied here, but we just don't see the second part because we have 0 times. So that's going to give me dx dy being 1 over y times the log of a to the base e, which if we want dy dx, we're just going to invert this. Dy dx is equal to y times the log of a to the base e. And from the beginning up here, as y is equal to a to the power of x, dy dx becomes a to the power of x by the log of a to the base e, or the natural log of a. So we don't really need to do this within leaving cert maths. Most of the time we're just asked basic differentiation with these log and natural log functions. So let's have look at a couple of questions in relation to this. In this question we're asked to differentiate the function f of x is equal to log to the base e of the square root of x squared over x squared plus 1. Now in a lot of questions like this, we may need to apply the rules of logs before we actually start the differentiation part of the question. So if we change f of x into log to the base e times x squared over x squared plus 1 to the power of a half, we can apply the rule that we saw earlier in this video, where this is the same as a half times the log to the base e of x squared over x squared plus 1. Now we can apply the division of two logs rule, and the division of two logs is one log take away another log. So we're going to have a half times log to the base e of x squared minus log to the base e of x squared plus 1. And we can now apply that same rule again with the power in here. So we're going to get a half times twice the log to the base e of x minus log to the base e of x squared plus 1. At this point we should be able to differentiate. We can actually multiply the half by the 2 first. Let's multiply the half by the 2 first. So we're going to get, that's just going to give me log of x to the base e minus a half log to the base e of x squared plus 1. So that's tidied up enough now. So now that's f of x. See a bit of tidying up involved before we get to f prime x. So f prime x, the log of e to the base x, natural log of x, goes to 1 over x. And we've seen this one already from the previous example. This is going to be minus a half times the differentiated part on top, which is 2x, the differentiated bracket, and on the bottom the original function, x squared plus 1. So this is going to give me 1 over x minus 2x over 2. Actually, I can cancel my x. 2 times x squared plus 1. So it's going to give me 1 over x minus x over x squared plus 1. And if we combine these two denominators, we're going to get x by x squared plus 1. And on top, 1 by x squared plus 1 minus x by x, which is going to give me x squared plus 1 minus x squared. That's going to give me the 1 on top that we were looking for. And x cubed plus x on the bottom, which is equal to 1 over x cubed plus x, which is what they were asking us to write. Just double check, right in the form, 1 over x cubed plus x. So a in this case is equal to 1. So we've no coefficient of x, the 1 that's there. So that's this example. So practice these questions in exercise 13.8, and then we'll have a look at some of those in the next video.